Let us understand ANOVA, the finer nuances of that and the math behind it using an example. So here is an example of weight reduction programs. Suppose a nutrition expert would like to do a comparative evaluation of 3 diet programs: Atkins, South Beach, and GM diet program. And suppose that she randomly assigns a few of the participants to each of these programs, and I have the corresponding data set available. Here it is. Oh, where did that go? Here we go. So we have this diet program, and to each diet program, this nutrition expert randomly assigns 12 people. That's the count. 12 people each. So in total, you have 36 people. So I'll go back to that presentation and show you that also later on. So say there are 36 people. This nutrition expert randomly assigns 12 of them to Atkins diet program. She randomly assigns another 12 people to South Beach diet program, and she randomly assigns, or the remaining 12 people are assigned to GM diet program. All right. And the people who are assigned to Atkins diet program, South Beach or GM, all these 12 people tend to lose some weight. So here we go. This is the underlying data set. The first person has lost 6 kgs, second person has lost 2 kgs, third person has lost 3 kgs, fourth person has lost 4 kgs, so on and so forth. When you look at the average weight loss of this diet program, of these people there, average happens to be 4.5 kgs. So the average weight loss of people who are assigned to Atkins diet program is 4.5 kgs. And the average weight loss of people who are assigned to GM diet program is 5.3 kgs roughly. If you can round it off to 2 decimals, it will be 5.3 kgs. And the average weight loss of people who are assigned to South Beach diet program is 7 kgs. Yeah, so you have these 3 scenarios. And if I take grand average is average of averages. So if I take an average of all these averages, we get 5.6. If I truncate it to 1 decimal, there is 5.6. So this is the grand average, and you have average for Atkins, GM and South Beach. 4.5, 5.3 and 7. Those are the values which are provided to us here. The average weight loss of Atkins, South Beach and GM diet program are provided here. What can we conclude? We should not jump in and say that, hey, South Beach diet program is great. Why? Think about this scenario. Say you have 12 people assigned, 1, one, 2, 3, so on and so forth. Say you have 12 people assigned to South Beach diet program. Say person 1 loses 2 kgs, person 2 loses 1.8, 0.8 kgs, person 4 loses say 1.7 kgs, so on and so forth. And say one person loses 20 kgs. So if you look into simple average, you know for a fact that the mean or average is influenced by outliers. Hence the single value can give you on an average a value which is very high. Hence we should not always restrict ourselves or an analysis to the average. That is the reason why, though on an average, the South Beach Diet Program, the people who are assigned to this South Beach Diet Program, on an average, they have lost a lot of weight in comparison to Atkins and GM Diet Program. Despite that, we cannot conclude that South Beach is the best because there could be outliers. Hence, we also need to look into variance. We need to look into the variance also, and hence this specific technique is called as analysis of variance. Okay, let us move on and try to understand further on what's happening. Look at this. So you have scenario 1 and you have scenario 2. In scenario 1 and 2, in both of these places, the average weight loss of each and every diet program is the same, and the grand average is also 5.6 in both these scenarios. In scenario 1, you see that the variation in the weight loss of participants assigned to Atkins diet program is less in comparison to scenario 2. So here, the average weight loss of each and every individual is, the variation is a little less in comparison to this. Variation less is always a good scenario. Yeah, I will tell you why. All right. And then you have GM diet program. The average weight loss of all these people are more or less the same. The variation is very less in comparison to scenario 2, where the variation is very large. And from the South Beach diet program perspective also, you see that the variation in scenario 1 is less in comparison to scenario 2. What does this indicate? The weight loss of people in Atkins diet program is more or less the same. So the people who are assigned to this diet program are losing more or less the same weight. But the people who are assigned to Atkins diet program in scenario 2 are losing varied weights. And the weight loss is in sync with your South Beach diet program also. What does that mean? Say 5.3. A person who is assigned to Atkins diet program also loses 5.3 kgs, and a person who is assigned to South Beach diet program also loses 5.3 kgs. So there is an overlap. We really don't know how much weight a person assigned to Atkins diet program loses, how much weight a person assigned to South Beach diet program would lose, because there is a lot of overlap, significant overlap there. So in scenario 1, you can effectively say that the variation of weight losses within each and every group is less, which is a good scenario. Within group, the weight loss, the variation in the weight loss is very less. But here it is very large. So there is a lot of uncertainty on how much weight people will lose if they are assigned to specific diet programs. This is one scenario. Within group, variation should be less. And to differentiate between these 3 diet programs, the variation between the groups should be more. Between the groups, the variation should be more. Only if between groups the variation is more, you would be effectively able to differentiate the people assigned to these 3 different groups. However, here there is a lot of overlap, so you cannot differentiate the weight loss of a person assigned to Atkins with that of a person assigned to South Beach. You cannot differentiate the weight loss of a person assigned to South Beach with that of GM diet program. Hence, scenario 1 is a good scenario for us. And since we are also looking into variation alongside looking into the average, you call this as analysis of variance.